Okay, we want to prove that the limit as x approaches 0 sine x over x is equal to 1. The key is to use the Sandwich Theorem, and so we need to find some way to pin the function sine x over x between two other functions whose limits as x approaches 0 are in fact 1. We can do that then by the sandwich or squeeze theorem, depending on your mood at the time of the day. We will be guaranteed that the limit as x approaches 0 of sine x over x is in fact 1. So here's how the proof works. We have three areas here shaded in blue, and hopefully you can see because how they're set up that the areas get progressively smaller. So we can say that that area is greater than the area in the next picture, which is greater than the area in the next picture. Now, what exactly are these areas? Well, using your definition of trig functions, we have an angle theta and a right triangle. We have one side is 1. We know that tangent theta is equal to the opposite, right here, over the adjacent. So tangent theta would be actually equal to that thing over 1, or just that thing. So that thing is in fact actually then tangent theta. So now that we know the height, we know the base, we know the area of a triangle is 1/2 the base times the height. So 1/2 of 1 times tangent of theta, or as I would prefer to write it, tangent theta over 2. Now to compute the second area, you're going to have to reference how the sector area works. Okay. Sector area for a circle, you may recall, area is 1/2 theta r squared. It's the area of a sector of a triangle. You can refer back to your pre-calculus days to find that. So since we know that the radius of this circle is 1, we have a circle with radius 1, sector is dependent upon the central angle. So it would be 1/2 theta times 1 squared, or as I'd prefer to write it, theta over 2. So we now know that tangent theta over 2 is greater than theta over 2. And then finally, moving to this last guy, to work with this last guy, we recognize that we have a triangle. The base is 1. Well, what about the height? Well, if we drop the perpendicular, remember the other side's also 1. We know that sine of theta is the opposite over the hypotenuse. So that side, that's the opposite over the hypotenuse. That side over 1 would be equal to sine of theta. So therefore this side right here, the height of this little triangle is sine of theta. And so by the area formula, area would be 1/2 the base, which is 1, times the sine of theta, or as I would like to write it, sine of theta over 2. So now we've brought the sine of theta into play. So now let's get rid of some fractions here. We have that common denominator of 2 in all those inequalities. So I'll multiply through by 2. That'll leave me with tangent theta is greater than theta, which is greater than sine of theta. Now, I'm going to take that expression, pop it on over here to the next page, and then notice that what I now want to do is divide everything by sine theta. And that'll get me my theta and my sine together. Now I'm able to do that because I have no worry about sine of theta being 0, because I'm taking a limit as theta goes to 0. As theta goes to 0. So, since I'm taking my limit, it's never actually going to be 0. So I'm not dividing by 0. I'm completely sure of that now. So, rewriting that, tangent theta is sine of theta over cosine of theta. I'm dividing by sine of theta, which is the same as multiplying by 1 over sine of theta. That would give me theta over sine of theta, and then that's greater than 1. Simplifying gives me 1 over cosine of theta is greater than theta over sine of theta is greater than 1. Now that's almost what we want. To get what we want, we use a little known property of inequalities, ones that you probably haven't talked about very much in algebra, and that is that you can take the reciprocal. You can take the reciprocal of each thing. And when you do that, though, it's going to reverse the direction of the inequalities. Now, I'm just going to move off to the side here and demonstrate this for you, because this is the one place where I think you may have a little difficulty with that idea. And consider the fact, if you had the inequality 2 is less than 4, and you decided to take the reciprocal of both sides, you'd have 1/2 and 1/4, and of course, by necessity, the inequality would have to reverse. Okay, so now we have penned sine of theta over theta between cosine theta and 1. Now, if only the limit is theta goes to 0 of cosine theta would be 1, and the limit of theta goes to 0 of 1 would be 1, we'd be done. Well, that's quite frankly exactly what happens. Oh, shoot. Okay, I'm not sure where I stopped recording here. So I'm going to leave what I have here up so you can see the process. We go through some manipulations, the one key being this reversing the direction of the inequalities by taking the reciprocals. Again, an example is 2 over 4. Take the reciprocals, you get 1/2 greater than 1/4. That leads us to our result.